What is the value of the green area? Label points C, G, and K. Locate the center O and let A be the radius of the semicircle. Line B, C equals A, which equals to 4 centimeters. It is because the opposite side lengths of a rectangle are equal. This implies that all these lines are each equals to A, which equals to 4 centimeters. Join line B, D. Line G, C equals 2 times A, which equals to 8 centimeters. The result equals to 2 times R. Consider triangle ABC. Let angle BAC equals to beta. Line BC divided by line AB equals to tan beta, which equals to half. We call it equation 1. By trigonometric identity, the sum of 1 and the square of tan beta equals to the square of the reciprocal of cosine beta. Substitute value from equation 1. The sum of 1 and the square of half equals the square of the reciprocal of cosine beta. Cross multiply and solve for the square of cosine beta. The square of cosine beta equals to 4 divided by 5. Take the square root of the equation. It implies that cosine beta equals to 2 divided by the square root of 5. We call it equation 2. It follows that line AD divided by line A, B equals to cosine beta. Substitute equation 2 and we have that line AD divided by 8 equals 2 divided by square root of 5. This implies that line AD equals to 16 divided by the square root of 5. We call it equation 3. Since line PD is parallel to line AB, draw a perpendicular line from point D to point K. Angle D equals 90 degrees. Hence, angle ADP equals beta, which equals to angle DAB. This is because alternate angles are equal. Consider triangle ADK. Line DK divided by line AD equals to sine beta. Substitute equation 3 for line AD. It follows that line DK divided by the ratio of 16 is to square root of 5 equals sine beta. We call it equation T. By trigonometric identity, sine beta equals the square root of 1 minus the square of cosine beta. Substitute value of equation 2. It signify that sine beta equals 1 divided by the square root of 5. After substitution and simplification of value, we call it equation 4. Line DK divided by line AD equals to sine beta. Substitute equation 3 and equation 4. Line DK divided by the ratio of 16 to square root of 5 equals 1 divided by the square root of 5. Cross multiply and we have that line DK equals to 16 divided by 5 in centimeters. After simplification of substituted values, label point F and join line FP. Also, join line OP and line OD. Each equals to R, which equals to 4 centimeters. Since line DK equals line FP, it is because opposite side lengths of a rectangle are equal. Use Pythagoras theorem. The square of line OK equals the square of line OD minus the square of line DK. Substitute values. The square of line OK equals the square of 4 minus the square of 16 divided by 5, which equals 144 divided by 25. Take the square root of the equation. It implies that line OK equals the square root of 144 divided by 25, which equals 12 divided by 5. The result equals line OF. Triangle PFO equals to triangle DKO. It is because congruent triangles are equal. This implies that line KOF equals 2 times line OK, which equals 24 divided by 5. But line KOF equals line DP, which equals 24 divided by 5. We call it equation 6. This is because opposite side lengths of a rectangle are equal. It follows that area of triangle PDA equals half the product of line DP and line AOD times sine beta. Substitute values from equation 3, equation 4 and equation 5. It implies that area of triangle PDA equals 24 divided by 5 times the product of 16 divided by the square root of 5 and 1 divided by the square root of 5 times half, which equals 192 divided by 25 in square centimeters. But area of triangle PDA equals the green area. Therefore, the green area equals 192 divided by 25 square centimeters.